In this video, we are going to talk about factoring higher order polynomials, meaning higher degree. So if I look at number one looks a lot like a quadratic trinomial, like when we had x squared plus 7x plus 10 equals 0. And we're actually going to factor this very similar to this, where we're going to think about things that multiply to 10 and add to 7. But notice I have an x to the fourth. So x to the fourth would become x squared times x squared, which is also how we're going to get this to be x squared versus x. Now to think about things that multiply to 10 but add to 7. So in this case it'd be positive 2 and positive 5. So my factored form would be x squared plus 2 and x squared plus 5. Now to solve this, I would set each of my factors equal to 0. And solve. So we're going to get two sets of imaginary solutions. So I'm going to get plus or minus square root of 2i and plus or minus the square root of 5i. So my four solutions are going to be plus or minus I square root 2 and plus or minus I square root 5, or square root 2i square root 5i, either way. All right, let's do the same for number 2. So again, this is a perfect square, so I know that I'm thinking about what multiplies to x to the fourth, which is going to be x squared and x squared. What multiplies to 16 but adds to 0 is going to be negative 4 and positive 4. Now this minus 4 will actually factor again, but the plus 4 will not. So my final factored form will be x minus 2, x plus 2, x squared plus 4 is all equal to 0. So to solve, I'm going to set each of these equal to 0. So add 2. One of my solutions is x equals 2 minus 2. So my other solution is negative 2. And I'm going to end up taking the square root of a negative number again, but this time 4 does square root, so I'm going to get plus or minus 2i. So I get 4 solutions for this one, just like I got 4 solutions for the other one. All right, let's try the same idea with 3. So again, I have x to the fourth and x squared, so I know that's x squared times x squared. I need to think about two numbers that multiply to 9 but add to 10. So things that multiply to 9 are 1 and 9, 3 and 3. But again, they got to add to negative 10. So I also remember I could have negative 1 and negative 9, or negative 3 and negative 3. So it's going to be negative 1 and negative 9. But those actually factor again. These are both the difference of squares. So this will factor into x minus 1, x plus 1. And this will factor in x minus 3, x plus 3. So I have x minus 1, x plus 1, x minus 3, x plus 3, all equal to 0. So now to solve this, I would set each of these equal to 0. Add 1. One of my solutions would be 1, minus 1, negative 1. Add 3. Positive 3, minus 3, negative 3. Or you could have said plus or minus 1 and plus or minus 3.